Okay, let's take a look at this problem. They want us to identify the relative extrema, so that means we're looking for a minimum or a maximum of this function here, 9 times x squared minus 3 over x cubed. Well, we notice that x can't equal 0 in this problem, so maybe that's helpful or not. Let's just identify that. Well, so in order to do the relative extrema, we're going to have to, first of all, take the first derivative. So this is a nice problem here. This is a quotient rule, so we're going to say that f prime, so we're going to identify this as f and this is g. So the first derivative of the top would be what? We have our multiple out here, so we have 9 times 2x, the derivative of minus 3 is 0, times the bottom minus the derivative of the bottom is what? 3x squared. And not touching the top, we have 9 times x squared minus 3. And then take this, square the bottom, so we have x to the third squared, or x to the sixth. So let's see, before we go multiplying anything, this becomes 18x to the fourth. We have x to the third, x to the fourth, 18. Okay, that looks good. And over here, let's see what we have. We have 27x squared times x squared minus 3. Maybe we'll just leave that like it is. Let's see here. Simplifying a little further, we notice that what's common here is a 9, and they each have at least x squared in it, right? So let's factor that out. We have 9x squared. That leaves me with what? 2x squared minus 3 times x squared minus 3. And on the bottom we have what? X to the sixth. Let me take it up here to save space. We have an x squared on top, x to the sixth. So the denominator we know can be reduced by 2. So we have x to the fourth. And on top we have just 9. And let's see if we can clean this part up a little bit. We have a minus 3x squared. And then we have a positive 9. Negative 3 and negative 3 gives me positive 9. So let's see what we have here. We have 2 minus 3x squared. So we have 9 and a negative x squared plus 9 all over x to the fourth. And I haven't been doing a very good job of this, but that's the first derivative. Okay, well, what are some possible critical values? Well, the first derivative is equal to 0 or undefined at what? Well, it's undefined when x equals 0. But is that a critical value? Remember up here in the original statement we said that x cannot equal 0. So this is not a critical point because it's not in the original domain. So all we really need to look at is the numerator. Well, when does the numerator equal 0? Well, the only thing that has to do with x's is this statement here, negative x squared plus 9. So we're going to set that equal to 0. Move the negative x squared over, and you have x squared equals 9. Well, that occurs when x is what? At plus or minus 3. Alright. Well, let's take a look at um, at this problem here. And let's just look at the positive side of it. Let's look at when x equals 3. So let's take our derivative and let's see what happens here. Let's look at 3. At x equals 3, this is our first derivative test, so we're going to use this value right here. We're going to plug in a number to the left and a number to the right. Remember, we can't use 0, so let's use 1, because 0 is undefined in the function. So let's use positive 1. Well, look at the denominator. It's x to the 4th power. That's always going to be positive. So we don't really need to look at the denominator so much. So what do we have here? We have positive 1 squared is 1, so we have a negative 1 plus 9. That's clearly positive. So the function is increasing. And we know at 3 it's equal to 0. Plug in a 3 and you get a negative 9 plus 9 is 0. And just try another value like 4 here. Positive 4 is a good candidate. We have 4 squared would be 16. A negative 16 plus 9 is negative. So the derivative becomes negative over in this interval, indicating that this function is decreasing. So what can we say? We have a relative what? A relative max. And the justification is we have a relative max because the first derivative changes sign from positive to negative at x equals 3. Okay, so hopefully this helps you out a little bit. Try a few practice problems, and good luck.